Okay, so today we're going to talk about the product rule. We're going to start off with an example and kind of segue into this idea of what the product rule is, or in other words, product of a powers property. So the example up here says, how many factors of 2 are there in the product 2 to the third times 2 to the fourth? Use the answer to write as a single power of 2. So if I write out 2 to the third, I can write that as 2 times 2 times 2. Now if I write out 2 to the fourth, I can multiply 4 more 2's. And you look at this and say, well, how many twos are there? There's 1, 2, 3, 4, 5, 6, 7. So when all the dust settles, if I do 2 to the third times 2 to the fourth, I could write this as 2 to the seventh. And you ask yourself, well, what do you notice about these exponents and the exponent I got when I was done? And this leads itself to the product rule. So 3 plus 4 gave us 7, meaning that if I have like bases, some a, in this example I use 2, but if I have any like bases, then when I multiply, I can add the exponents, and that's the product rule, is that the addition of the exponents, 3 and 4, which yielded 7, all right, occurs because I have like bases of 2, and when I have like bases of 2, then I can just add the exponents, and that is the product rule. So we're going to see it in a bunch of lights. We're going to see it also in an example where it may not work. So let's just run through these examples. There aren't a ton of them, and you're going to apply this for your homework for this week. So the first example, you'll notice that I have a base of 3 and a base of 3, and I also notice that this is a multiplication symbol, so I can use the product rule because I'm separated by multiplication. In this example, I can write this as 3 to the 3 plus 4. And then I could say, well, 3 to the seventh because 3 plus 4. I think a big deal here to notice is that I did nothing with the bases. A lot of people do 3 times 3 and write 9 here. Notice how the base stayed the same. Up here, I didn't change up what it looked like. A and A just gave me an A. So I'm only working with the exponents. You're only working with exponents in this examples. You're not changing the bases. You're only working with exponents. Let me show you again. So I have a base of 2 and a base of 2, also separated by multiplication. So now I can use the product rule or product of powers property. I could write this as 2 to the seventh plus a negative 5. But adding a negative is really just subtraction. So I can write this as 7 minus 5, which gives me 2 squared. Again, notice how this didn't become 4, right? I'm just keeping the bases the same and focusing so much on the exponents, right? The bases aren't going to change provided they are the same base and performing the operation. Another thing I want you to notice that I'm not simplifying this any further. All right, we're going to see why next week, while this is very crucial to stop here. Of course, you could write this as 4, but I want you to leave it as 2 squared, in this example, 3 to the 7th. Let's take a look at these examples. Right down here, I have a negative 5 as a base and negative 5 as a base, which is fine. It's a negative 5 is going to be my base here. But I want you to pay attention to is I need to add the exponents, the 5 and the 3. So 5 plus 3. Right, in that instance, I get negative 5 to the 5 plus 3, which gives me negative 5 to the 8th. All right, and that's what I'm going to look at, is that since the bases are the same, separated by multiplication, I can add their exponents, and 5 plus 3 is going to give me 8. Again, I did nothing to the bases here. Of course, I can go through and simplify this further if I wanted to, but I don't have to. Now let's look at it in the scheme of 3 bases. Right? If you notice, for every single example here, I have a base of 4. So if I'm looking at this and I'm trying to use the product rule, I can use the product rule for all these bases at once. I think the big thing to notice is that the base for this one, or excuse me, the exponent for this one, if it's missing, is always going to be a 1. So if you're missing an exponent, feel free to put a little 1 in there to let yourself know, meaning that I could do the product rule for all 3 of these. 1 plus 3 plus 2. Based off of this, I can add them all up, and that's going to give me 4 to the 6. And again, I'm not going to simplify any further. I'm just strictly looking at the exponents. And again, I did nothing to the bases. This didn't give me 4 times 4 times 4, which is 64. I left it as a base of 4. So let's talk about scenarios where you can't go any further, or you can use the product rule and not so much in the back end here. So again, you'll notice I have a base of 2, a base of 3, and a base of 2. Meaning the ones that I can apply product rule to are these ones right here. The 3 is not similar. It does not have a similar base, so I can't do anything there. And I would focus on just doing 2 to the 6 plus a negative 4, and then I also have that 3 squared out there. And 6 plus negative 4 is going to give me a 2. All right, and as we move forward, we'll talk about how you could evaluate this further. But for right now, because these are unlike bases, I would stop. Okay, so this is where I'm going to stop because I cannot use product rule here. I cannot make this 3 to the 4th or 2 to the 4th, right? I would stop there. The last thing I want you to pay attention to is this example off to the right. If you notice here, every other example had multiplication. Now we have addition, meaning I can't do anything with that. I can't turn this into 3 to the 11th. I can't even write this as, I don't know, what else would you guys do here? 6 to the 11th, right? These are unlike terms, meaning that I cannot add these. So my answer to this is literally 3 to the 4th plus 3 to the 7th. Pay attention to these ideas that the rule states that if I have similar bases separated by multiplication, I can add the exponents. That's the only rule you're looking at for your homework tonight. Look for like bases, which leads me to add the exponents, and sometimes I can do 3 at once.